First of all, I need to inform you, you have good news. We have that lucky draw session, as Daniel presented. We have Note 10 Plus device, brand new Note 10 devices, and one device, and the t-shirts. If you win the lucky draw, you can get it here. If you do not get a ticket, please go to door, and ask one of our staff for a ticket. Okay, I think you have joined the last session in the SDC. Most of them are somewhat serious, but you can be somewhat relaxed because it's the game, title is game. So I think first of all, we need to introduce ourselves first. My name is Choi. I have been working for Samsung Electronics 20 years. It's a long time because my father is working for government 35 years. I realized that I almost halfway through. It's really low, but I have been working for Samsung Electronics 20 years anyway. My background is a system BSP and Linux kernel and optimization. And I moved back to that graphics and then make Gear VR. I'm one of the creators of Gear VR, and I introduced Daydream VR to the Samsung devices. And now I'm leading a game performance platform. This is brief explanation for me and my colleague, Daniel.
Hi, nice to meet you all. My name is Daniel Ansorregui, and I come from Samsung Research UK, where I have been working for 6 years. And I started as a GPU engineer, running simulations, really optimized computing. And from there, I moved into using GPUs for gaming. And most lately, I have been focusing on machine learning applied to gaming, and specifically reinforcement learning, which is what I will talk about later.
Okay. He'll be in charge of the 2 sessions, game performance platform and the AI technologies. Okay, then let's get into contents. First of all, we will go to overview, the kinds of some problem statement we have, and then what is the solution we have, the game booster, game performance platform, and then goes to that example, how we that come up with this problem and best example, and we will tackle somewhat about next session, game performance index. And finally, your favorite, lucky draw. Okay, this is overview. So we need to tackle about the game performance. What is game performance? It's quite different from that your imagination, because it's somewhat different from the PC and console. As you can see, that diagram, trend is changing, means that more than 45% of the revenue comes from the mobile game. Previously, it was occupied by more than 50% on PC and console, but it's gradually overtaken by mobile. Nowadays, that mobile increased more than 10% per year, that overtaking all of the PC and console business. But what is the problem here? Means that we can think 2 problems. First one is that game developer is kind of greedy. They want more resource-intensive tasks. It makes heavier on the mobile. And the other one is that PC and console problem, console game moves to mobile. What is this problem? This problem is quite simple. Both have that different environment. If you think about that PC and console has unlimited resources, means that you can have more power and larger space in between a component. And the other one, cooling system. You have the water cooling system and fascinating air cooling system. And even you can work with overclocking technology. So we can say that AP performance is almost directly matched to the game performance. We can agree that. But the problem is, none of this applied onto mobile. Mobile cannot use the wall power. It's restricted on the battery. And it uses that none of this cooling system. It cannot make overclocking or something like that. The other problem we have is that game characteristic. There's lots of genre of game. Every game genre has different characteristics. It is almost not possible to change its optimization based on manually. If you need manual optimization, you may need more than 10,000 engineers on site. So I can say that it's kinds of some different performance challenges. So I can define performance, game performance, mobile game performance here, how well a mobile phone does a game, not AP performance. So that kinds of some problem statement will keep going on. So what is solution for the Samsung Game Booster? So we call it Game Booster. From the Note 10, we desynchronize as it one Game Booster. So we can introduce what is Game Booster. First of all, I need to introduce what is a Game Booster. We made the concept of the game, we have the three concepts of major Game Booster. So first one is the only one Samsung device can provide performance optimization for the game. So all activities for the Samsung game performance optimization belongs to Game Booster. Second one, it gives you total solution from bottom to top. Means the device level to application level, it has all solution to you and to user. Finally, it connects everywhere and anywhere. Means that previously Samsung is isolated in the world. But we are claiming to that in the future for the game performance, we are connecting to that other people and other companies as well. So what is the key technologies on the game boosters? As I mentioned before in the problem statement, we have lots of challenges. Two challenges before means that AP performance is quite different from the, how can I say, means that PC and console, it uses just AP performance. But we cannot say that AP performance is directly matched to the game performance in the mobile. Second one, it is not possible to characterize game at once. So we introduce two technology. First one, on-device AI, and the other one is big data. We have on-device AI can measuring game performance as well as tweaking game performance, but the only AI cannot satisfy this requirement. So we introduce big data technology can assist the game AI and ML. We will tackle in detail on later slides. The other one is that I say the basic principle of that game booster. One of the major concepts of game booster is connect everywhere. So we want to connect other partners and users. We have made the interface for the connection to user and our partners. That Daniel will explain it later on in detail. So user benefit. What is the user benefit? Having said that, the final benefit should be on user hand. A user need to know what they have and what they tweaking. So Game Booster application itself has the interface, can show up what is the benefit for user and what they can tweak it. So it is quite important matter. So I can show the demonstration on later. All of the game performance platform means that game performance platform is beneath on the Game Booster. Game performance platform's activities should be displayed on the Game Booster. So we have lots of improvement on the Note 10 based on Game Booster. So this is outlook of the Game Booster, means that on the top, they can know what is their benefit, and it is possible to automatic tweaking and automatic device care if there's some memory and temperature issues, and plugin can cover up their tweaking as well. And what is the developer's benefit? As I mentioned, we can connect each other for developer and Samsung. They can connect Samsung performance platform beneath the Game Booster and gather information and tweaking their game. So there's two types of the collaboration. First one is large-scale collaboration, such as the game studio and game publishers. It is possible to server to server, server to device, and application to device collaboration. Each individual game developer can use the plugin interface to come with. It is ARDA based, so you can easily use Android interface to make it, and you can use Galaxy Store to manage it. So it's time to move on the detail on our solution. Our ML and AI expert Daniel will explain detail about this one.
Thank you very much, Ted. So as Ted was saying before, we have Game Booster, which is a total solution. But behind the scenes, at the system level, we have what we call the game performance platform. That is what actually internally modifies the parameters inside the user device. So the game performance platform, it's an holistic approach to game performance in mobile devices. So it has 4 major components. The first one is the games themselves, because the games are what the game performance platform is trying to improve. We have the system and hardware, where the games are running on top of, and also the AI and machine learning is modifying. And then we have the big data that contains all the previous information about previous executions of those games into that hardware. And the glue that unifies all together is the AI and machine learning that is able to get this data from the big data and decide what to modify in the parameters of the hardware in order to improve the gaming experience. So if we move into the internal component view, as I was saying before, we have the game booster at the UI level, which is what the user will interact with. And then we have the platform side, the game performance platform. So inside the game performance platform, we have the machine learning engine that connects with the system components and hardware, and also connects with the Samsung big data through the internet. So as you can see here, all the models are tightly coupled between them, but even though they are interconnect a lot, they are upgradable through the store. So all the machine learning engine, as well as the game booster, can be updated. And also it's designed to be modular, so multiple versions of the game performance platform can interact with multiple versions of the game booster or the hardware. But I think the important part for you is how you can interface with the game performance platform. And as Ted was saying before, there are multiple ways to connect. So we have external connections that happen at the cloud level and through the internet, and we have connections inside the user device itself. If we move into the external connections, there are 2 types of ways to collaborate. The first one would be connecting with the Samsung's big data server and exchanging information at that level. And the second one, which is a more ambitious one, it's to directly connect with the user devices. But obviously, that external server would need to be able to cope with all the users. So the benefits of this type of collaboration is, first, to be able to get summary data about the gaming performance, like the duration of the gameplay, the average FPS, the battery usage, and so on. The second benefit is that it's possible to configure some global parameters that would affect the gaming, specifically features that affect the machine learning engine, like the mode it runs or the maximum FPS or certain things like that. And last, it allows A/B testing, what features you want to change in order to maximize the gaming experience. But not everyone can do this type of collaboration through the external server. So for that reason, we also have internal connections inside the user device to be able to interface with the game performance platform. So if you attended the talks yesterday about game SDK and adaptive performance, so those things are using this interface to modify the hardware performance. So this interface uses AIDL, and the good thing about it compared to the other one, to the external one, is that it allows a real-time exchange of information. So it's not possible to send all the information to the cloud. So as I was saying before, to the cloud we may be able to send average FPS. But inside the user device, there is no limitation about interfacing the game and the game performance platform. And for that reason, the benefits we get are very high detail information about the FPS, the power usage, and even the device status. But that's what the game can read from the game performance platform. But it's also possible that the game hints something back to the game performance platform that affects how the game performance platform behaves, specifically the machine learning engine. So if the game communicates its own state, like it's in a loading screen or it's in a menu, back to the machine learning engine, this allows it to do better decisions. And for example, if the game is in a critical situation, meaning that if the FPS drops in that particular scene, the user may lose the game, the machine learning engine will do more effort in order to avoid those FPS drops. And later on, we'll talk more about this. So in summary, there are multiple ways of collaborate. You can even mix and match all of these ways. And the benefits we get is that the gamers will get a better gaming experience. They will engage with the game more and play more. And the developers will get insights that are otherwise really hard to obtain. But I think that in order to have a better collaboration, you need to understand a little bit more what kind of things you can exchange with the platform, and also be able to understand what kind of decisions the platform does. And for this reason, I'm going to dive into the machine learning engine. So the machine learning engine is the centralized place where we are going to make decisions that affect the hardware and ultimately the game that is running on top of the hardware. So the machine learning engine is configurable from the big data and also the plugins and the interfaces I talked before, and reports all the metrics back to them as well. So it's completely device and game agnostic. And the major two components it has is first the adaptation layer that abstracts the machine learning engine from different hardware. And it's also a very good thing because it makes all the metrics be generic. So from the outside, you don't need to care about the specifics of the hardware. And the second major component is the reinforcement learning that is making the decision itself. So one question sometimes people ask is, why do we need machine learning for solving this problem? And the reason is that the system is not something unidimensional. It's multidimensional. We have CPU, but the CPU is made of clusters. Each cluster is made of cores. It has multiple frequencies. The same thing goes for the GPU, which has multiple frequencies. System representing, I don't know, thread priorities. We have multiple things that can be configured. So it's not a single value that has to be modified. It's a multidimensional problem. And for this reason, we need machine learning. So now I will go into what does the reinforcement learning do? What does the core do? So basically, it reads all the system parameters as input. It goes through this adaptation layer that unifies everything. And then it makes a decision that affects back to the hardware. The reason we use reinforcement learning is because it's really unfeasible to pre-train a model for all possible games, all possible devices, and even all possible user behavior. Because, well, games change all the time. Every update may change the performance. We have multiple games, multiple devices, and so on. So it's really impractical. Also, to download all this data to the user phone will be a big problem. So what the reinforcement learning core is doing is maximizing a goal. And it's training and storing everything inside the user device. Since all this pipeline runs while the game is running, it's really optimized. And from our tests, it uses less than 3% CPU of a single little core, so it shouldn't affect at all the resources that the game needs. And lastly, we have the safety layer, because for those of you that know how reinforcement learning works, you probably know that at the beginning, It has no data to work with, so it tends to do bad decisions, and for this reason, this can help with the cold start problem. So the reinforcement learning, the most important part is what is maximizing, what is aiming for. And I want to detail a little bit what are the goals the reinforcement learning is following. So the main goals are thermal, to get as low as thermal as possible, performance, to get the higher FPS as possible, frames per second, and stability. And what we mean by stability is that the frames per second does not change over time. So as you can see, the first two goals are a little bit conflicting, because if you want to get the maximum performance, the device is going to heat up. And for this reason, we have to progressively balance these two goals. And as we can see, that makes the goals be bidimensional. And the way we balance it is the higher the temperature, the less we are going to aim for stability, and the higher the temperature, the less we are going to aim for FPS. So it will find itself a spot where it stabilizes with best stability, performance, and thermal. But I think the best way to see how the system behaves is to see it in action. So here we have an example result of the system making decisions. In this case, the system is running a game that makes it heat up really quickly. So it hits thermal throttling situation after around 3 minutes. So we are comparing a standard thermal control and a machine learning engine-based thermal control. And I am not showing here the GPU because the graph is pretty much the same, so for simplicity. So what we can see is that straight away the machine learning at the beginning of the session is able to detect that thermal throttling will happen quite soon and starts reducing the performance from the beginning instead of waiting until 3 minutes and then dropping sharply. It's also able to find a better sweet spot for the frequency that is a little bit higher than the default thermal control. And as you can see, the graph is very spiky in the CPU frequency, and that's because it's able to detect when the game needs more resources, and it's able to give those resources to the game in order to avoid all the frame drops. Good. So lastly, I want to talk about the data-driven configuration that the machine learning engine provides, because it's the machine learning is very sensitive to what settings you configure it to do. It's not able to know in advance what is the best temperature or the best FPS. And for that reason, to have a loop between the machine learning engine collecting metrics, sending it to the big data, and then the big data downloading the configuration back, it simplifies a lot all the configuration process and allows us to configure settings for multiple devices at the same time. So now I will leave you back with Ted that will talk more about the big data.
Thanks, Daniel. I said I should thanks to the staging service for less nervous, but I should say now, sorry to staging service because they locate the clock from 45 and ticking is now 20 minutes remains. Anyway, I should remind you, we have the lucky draw session. If you do not have ticket, please go to gate and then get a ticket. You can have that free Note 10 Plus devices. And this is big data. As I mentioned, we have this assist from the big data. So this is detail of the big data. Can you imagine how many devices in Samsung in the worldwide? It's enormous. Means that we have several 100 million devices in the world. And based on our statistics, more than 60% of people gaming. So we collect this enormous data, but only this low data is not meaningful. So we need treatment. First thing we need to do is extract data from the low data. What is the meaningful data for the device? We have FPS, temperature, and game version, and current status, current device version, lots of device information come through to our server. But problem is that, how can I say, this data is not enough. We can use this data because it has purely that kinds of some device statistics, and we can use this data, but it's not accurate because device is worldwide. It has lots of that side effect. Not a side effect means that lots of that conditions to consider. What is the condition to consider? The environment change. Think about that Middle East. They have that sunny sky and dry land, have temperature about 50 degrees. How come we that are making best performance in the device? So we need to think about this one. So we collect another data such as environment and actual game playing time or something like that, and correlate it to the extracted data. So this is really validated data. Means that it's accurate and more kinds of some persistent and stable data we can make use of. So based on this data, as I mentioned before, we have AI and ML engine inside. We can do lots of things, even if there's no big data, but it's not correct 100%. So we feed in this big data to the ML engine to assist the AI and ML engine. AI, for example, if I can give you that example, the AI and ML engine can learn solely more than 80 to 90% of the accuracy, but 10 or 20% is still missing. So we feed it, that big data, to that feed up most of the situation. So ML engine is now fully functional with the assist of the big data. But the problem is the human beings. We made code, and you are a developer, so we know that we always make a bug. So it is possible there's some 1% or 2% possibility of the mistake. So we need to consider about that as well. So what we shall do is that lab testing. If there's some problem found, we lab testing the data, and if it is needed, we override it to make it correct. So finally, user have that corrected data, which is that 100% validated. So this is our scheme. So to sum up them, this is overall. First, we collect data from the lots of that our candidates, and then extract meaningful data from enormous data. And finally, analysis and correlate data with the environment changes, and feed into ML engine for reference. Finally, we have fallback line to depending some kinds of some bug. So these flows keep going on and make our game performance platform better. I think it's kind of some theoretical. Maybe some of you are slippery, but please remind we have the lucky draw at the end of the session. So please keep concentrate on 15 minutes, it says that. So this is an example of the plugin. As I said, we have the two scale of the collaboration scheme. First one is large scale, second one is that small scale. This is example of small scale collaboration. Each individual game developer can make use of the plugin structure to communicate with game performance platform to optimize their game and tweaking their game. Even user can use this application to tweaking their game. So this is overview and how it all looks. So if you have the Samsung device and has the latest version of the Game Booster, you can have the plugin option. Plugin is located in the Game Booster, and any developer can make use of it based on AIDL interface, which is similar to camera filter in Samsung devices. So you can freely write down your code and upload that into Galaxy Store, which is that management. So you can manage it easily, and it's very easy to control. What it is structure-wise, it communicates to our game performance platform. So each plugin connected to game plugin interface and goes through game performance platform which governs the all device game performance in Samsung devices. Currently, we are in the internal development, which is the Samsung internal game plugin is working on now. In the future, we will release SDK public. Developer can make use of it for their benefit. So this is the appearance of the game performance platform. It's plugin manager, and this is actual demo. It's procedurals. And if you enable Game Booster, you can see these kinds of plugin here. You can easily move, and you can use your UX, or you cannot. You avoid this UX and just control interface inside. And here you can have that kinds of some configuration routine. You can turn it off and configure the plugin as well. This plugin can be downloaded from the Galaxy Store. So what is scheduled for this one? We are internally working on this one. We will release lots of that plugins in this year and next year. And then next year, we have the end of next year, we have planned to go on public. Next one is large-scale collaboration, game studio and publisher. Thanks to the Tencent, we are collaborating with the Tencent. As I mentioned before, there's lots of the, how can I say, games from the PC and console. One of that title is PUBG, Battleground. It is kind of some resource-intensive game, and then we decided to collaborate with Tencent about the game performance. Samsung has its own game performance platform. Tencent has its own platform to communicate with it. So it is not difficult, but we need some task to do. So first thing we need to do is that collaborating each platform. The Samsung has game performance platform. Tencent has TGPA. TGPA stands for that Tencent Game Performance Emulator. We make a channel. Samsung, as Daniel mentioned, we have the contact point, the collaboration point interface in the game performance platform. Tencent has named the SDK to collaborate each other. So these kinds of scheme is working together. So Tencent, first one is we need to understand the Tencent TGPA. TGPA stands for the Tencent Game Performance Emulator, and it quantifies players' experience. TGPA server uses multi-dimensional player analysis to make a game performance perfect. It's majorly on game side because they do not have device, so they have tackle in game performance in game side. Besides, Samsung has the game performance platform. In the device side, we have control on the device. That is perfect match each other. So we make a connection each other like this one. So based on our concept and their concept, we connected our interface with Scene SDK to the Tencent TGPA. So information flows each other. We define what we need to do, deliver, and they need to deliver. Such as we can deliver device status. They can deliver game statistics or something like that. So final flow, the operation is quite simple because this is just bi-directional flow each other. Between TGPA and Samsung Performance Platform, there's kinds of some information flow in each other. It's Samsung device to the TGPA server collaboration. Game information shared for some specific scene, and it continuously goes and comes from the TGPA server. TGPA server provides scene ID, importance, targeted FPS, something like that to Samsung AI and ML engine. So each party uses each other's information to make the game perfect. As you can see, this diagram, Tencent TGPA SDK communicate with game application to make it better game. Samsung get information from the TGPA Zine SDK, the game information, and make it perfect on game performance. So both have that benefit, is win and win solution. So other parties, other that publishers, other studio can connect Samsung performance, game performance platform easily with the interchange interface, or you can use the server-to-server interface or game itself to the ML engine. It is possible. So this is the all of the game performance platform. But in the meantime, we are thinking about the game performance platform. Previously, I defined the game performance to that how well the game on the mobile. So we need to think about the well list. That is the problem. This is related to the next session, or that co-presenter will present. Because currently, there's the only standard for the game performance is the FPS or something like that. But FPS is fixed to 60 or 40 to 120, something like that. But it's too old-fashioned, and it is not possible to matching that performance to, how can I say, current mobile situation. Because as I mentioned, the mobile is quite different from the PC and console. So that FPS and that traditional value is meaningless. So we need something kinds of some new scheme to define something more. That is kinds of some game performance index. So new performance index should be defined for, so clear communication, easy to use, and simple to measure. And communication way between the user and developer and manufacturer and platform owner or something like that. So this will be on to 11A, 3 p.m., so please join the sessions as well. Okay, we have been through lots of that sessions in here. We have Game Booster and Galaxy Game Dev yesterday, AR Emoji yesterday. So lastly, we remains the Game Performance Index on to 11A. So please join Game Performance Index. This is a contact point. Ted is me, and Daniel's email. And index, we have another guys here. I'm not English is not my native tongue. It is sometimes not possible to communicate fluently. So you can send the email to me, or I can place my name card here. You can bring it to your office. Okay, it's time to lucky draw.
Thank you.